In this lesson, we're going to talk about inscribed angles in a circle. But before I get into that, I want to just review some vocabulary real quickly. In a circle, if you have from the center what we call a radius here, and we have two radii here, right? It creates what's called the central angle. Right? In previous lessons, such as arc length or finding the area of the sector, we used this central angle. And this central angle, let's say I know this central angle was 60 degrees. It has the same measure as this arc measure of our circle here. And I want to remind you that the total angle measure of a circle is equal to 360 degrees, right? So all the way around the circle would be 360 degrees. So let's keep that in mind as we go through this lesson. So an inscribed angle is an angle whose vertex is on the circle. So here you can see that this point C, it's on the circle, and whose sides are chords of the circle. Now, if you don't know what a chord is a line that intersects a circle at 2 points, as you can see here, A and C. A common chord that we actually know, that we use all the time, would be a diameter. A diameter is a type of chord because it goes through the center of the circle. It just happens to go through the exact middle, but it is still a chord. So this is still a chord even though it's not going through the middle. The intercepted arc is where these two chords, they intersect here and here at A and B. This is what we call our intercepted arc. It's an arc with endpoints on the sides of the inscribed angle. So it's opening up and hitting the circle at these 2 points. So one of the theorems of inscribed angles is that if you know this is an inscribed angle, as you can see here, it's connected on that point. Here's our intercepted arc. If you know this measure of this angle, B, then the intercepted arc in here, B, is 1/2 this arc measure. So unlike the central angle, where if I said this was 60 degrees, this arc measure would also be 60 degrees in our previous lessons, inscribed angles are 1/2 the arc measure. So for example, if I said this was 40 degrees here, the arc measure is actually 80 degrees. Right? So this is going to be the smaller angle measure. It's half of your arc measure. Let's look at an example. Now these examples can be a little challenging because there's a lot of things going on in our diagram. So it's helpful to use a highlighter or try to color in with colored pencils what you're actually looking at. The question is asking what are the values of arc measures A and the inscribed angle B. So we're trying to find out what are these missing variables. I can see here that on this point from P to Q to T, I know that this inscribed angle is 60 degrees. And based off our theorem, if the inscribed angle is 1/2 the arc measure, right, 1/2 this total measure, and I know this is 60 degrees, then I can actually double this number and say that A equals 120 degrees. Now, looking at this inscribed angle, B, that's where we connect from S to R to P. Okay, I know it's a little challenging to see, but you'll notice that from S all the way to P, that's our arc measure. And now that I know that this is 120 degrees from P to T, and T to S is 30 degrees, together these make up 150 degrees. From all the way across here, this is our arc measure. So our inscribed angle needs to be half that value. So B equals half of 150 degrees, which is 75 degrees. Let's look at a few examples. In this figure, I don't see any angle measures that are being shown here. However, you can see that this point is on our circle, and it extends out with these two chords here and here. Well, if this is going through the center of our circle, think about what is that total angle measure when it's only half of our circle. Remember, a circle is 360 degrees, so half of that would be 180 degrees. That would be our arc measure from this point all the way around to here. So if it goes through the middle here, our inscribed angle, if it's connecting through the diameter, then we know that's 180 degrees. That means the measure of angle A, our inscribed angle, has to be half that value, making this 90 degrees. Let's look at B. We're trying to find the individual angles inside this polygon, but I know all of the arc measures in this figure. So let's start with A. For A, it's from B to D for our inscribed angle. And I know the arc measure is 190 degrees. That's the sum of 190. So I know that this inscribed angle is half of that arc measure. And half of 190 degrees is 95 degrees. If I want to solve for B, I know that from this point to A and this point to C, that is our inscribed angle. So here we have from A to C as our arc measure. And so we can take our sum of 64 and 90, which would be 154, and we're going to divide it by 2 to get 77 degrees, because it's half these two combined. For C, I know that my arc measure created by that inscribed angle would be from B all the way to D. So if I add these two together, I get 170 degrees. And if I take 170 degrees and divide by 2, I get 85 degrees. And last, if I see this inscribed angle starting at D, it connects with A and C, which means the arc measure is 206 degrees, right? Going to combine those two together. And 206 degrees divided by 2 is 103 degrees. The previous two examples in the lesson check actually went over two of the corollaries of our theorems. This corollary 2 is an exact example of this here, right here. An angle inscribed in a semicircle is a right angle. So if this is our inscribed angle and it's connecting through that diameter, right, that half, then I immediately know that this is going to be 90 degrees. Corollary 3 says the opposite angles of a quadrilateral inscribed inside of in a circle, they are supplementary. Take a look at what we did in our previous example. 77 degrees. Once I actually found this angle measure, I could have said this was 103 from the beginning. It's just a quick shortcut. And same thing with here. If I knew this was 95 degrees, the opposite was actually supplementary. So that's just showing that corollary. But another one I want to point out is corollary 1. If I know that, let's say this angle measure is 40 degrees for our inscribed angle. And notice how this inscribed angle connects at these 2 points. Well, this angle for B also connects at those 2 points. So I could take the steps and say, okay, if this is the inscribed angle, then our arc angle measure is 80 degrees. But then if I'm trying to solve for B, I'm going to take that same arc measure, divide it by 2, to say that this is 40 degrees. It's going to be the same angle measure. And that helps us when we get to diagrams that are a little more challenging. Let's try some of these examples. What is the measure of each numbered angle? Now, just be careful. There is some information that is here to deceive you. some information in these diagrams are actually not needed. So let's look at A. You may see here that you have 40 degrees and 70 degrees and think you have to use both, and that's not the case. It is true that this angle measure here would be 20 degrees, and I'm just going to write that in there just so you have it. It's half of the arc measure, 40 degrees, this inscribed angle. But that doesn't help us solve the measure of angle 1. You'll notice here that this angle measure of 1 connects from here to here, creating our chords, our two chords. This is our inscribed angle, and it's connected through the semicircle because it's halfway through the circle. So I could actually say that this is 90 degrees from the start, because if the arc measure is 180 degrees, this is 90 degrees, half that arc measure. So all this information was actually not needed. And I'm just going to add something in here. If the arc measure of this is 70 degrees, the inscribed angle here would be 35 degrees. Again, not needed to solve this problem. Another thing you did not need to do, if our total angle measure is 180 degrees, here's our arc angle measure. So half of 110 would be 55 degrees. Eventually you would get to this solution anyways, but from the beginning you could have just found that to be 90 degrees. So again, not all information is needed, and it has more information sometimes. In this next example, again, you may look at this and go, I need to use all the information. However, if you try to highlight the inscribed angles, you may find it is a lot easier and you won't have to use all the information. Let's take a look. I know that this inscribed angle is 38 degrees, and it's created by these two chords. So our arc measure from this point to that point should be double 38, which is 76 degrees. Notice how we're trying to find the angle measure of the inscribed angle, angle 2, and that is also created by these two chords. And it so happens that they connect through the same points. So if this is the arc measure, 76 degrees, I can take half of this number, so angle 2 must equal 38 degrees. This 70 degrees was not needed to solve this problem at all. And it follows corollary number 1.